Hi class, here we are, our first video lecture. We're going to be talking about 6.1. As I mentioned in the announcement to you, we have a few sections that we've taken out. We're only going to do 6.1, 6.2, and 6.3. And then we have 7.1, 7.2, 7.3. And then we have 4 sections in section 8, chapter 8, and that is all we are doing for the rest of the semester. The way this should work is hopefully you've printed out the worksheet that I posted with this. In this particular case, it's really beneficial that you have it printed out instead of trying to write everything down, because in the matrices, there's a lot of numbers, and so that you don't get mixed up, I put a lot of them already printed, and you're just filling in the ones that we're changing. So hopefully you got that printed out, and then when you're finished with this video, you can take pictures of each of those pages and submit them for this assignment. To get credit for this assignment. Feel free to pause the video at any time. If you feel like you're getting behind, just put the video on pause or back it up or whatever you need. And the nice thing about this is you can listen to it over and over again if it didn't make sense the first time through. But hopefully the worksheet and the fact that you work along with me will help. So we are going to talk about matrices. So a matrix is just an array of numbers or items. And so you can see that this matrix here has 3 rows and 4 columns. Now this particular one has a line right here because this is an augmented matrix, and that kind of means that we're tacking on another row. It's kind of treated differently than the other ones, or another column. We do everything we do to a row, we do to the whole row, including that extra part. You can actually drop the line if you didn't want to keep writing it. But later we'll do some things when we're setting it up a little different, not an augmented matrix. But for right now, that's what we have. And we're going to use these matrices to solve systems of equations. And so this system that we have here has its 3 equations, 3 variables, and as you can see, we'll put the coefficients, so the numbers that are with the variables, in here. So it's just kind of shorthand. We're not going to have to write any x's or y's or z's, right? The numbers for the x's will go in this one. For the y's will go in this one, and for the z's will go in this one. And the answers will go in this one. Okay, now in order for this to work, of course, they would have to be in kind of a standard order. So they have to be written as the x term, and then the y term, and then the z term, and then the answer. All right, so we just put each one over. So this is a 2, a 5, -3, and a 4. I hope that you can read those numbers okay. So pause the video for a second and fill in the other 2 rows. All right, hopefully you have this filled in. It's going to be 4, -6, -1. If there's no coefficient, that's a -1. -7 is the answer on that one. There's a 1, 11, -6, and 2. And that is the matrix that we would use to solve that system of equations. All right, so here's another one. I want you to put this into an augmented matrix. This time we only have two equations. And you notice that this time they are not in the standard order, so you're going to have to rearrange them first. So go ahead and pause the video, rearrange these equations so they're in the general form, and put them into a matrix. Okay, hopefully you got that in. It should look like this. Now you notice that I did not have the line there. You can put it on or you can leave it off. Most of the time in the book, the printed ones will be left on. When I get to writing them and I'm writing matrices, I probably most of the time leave it off. It really doesn't matter. All right, so first we're going to talk about a method of solving systems using matrices that was developed by Carl Gauss. So he was a great mathematician. In fact, he was kind of famous even as a child. He was a mathematician that was brilliant, and we'll talk about him a little bit later in chapter 8. But this is called the Gaussian elimination. Okay? So when we start with a matrix, an augmented matrix that's coming from a system of equations, right? There are 3 row operations that we're allowed to do. And they fit really well with what we could do with equations, right? So you can interchange 2 rows. So it really doesn't matter the order that we got the system of equations, right? I mean, we can change the order. Now, when we do these row operations, we have some little symbols that we use. So a row, R with a sub 1 is row 1. R with sub 2 is row 2. Okay, so this is the symbol that means we're just going to switch their places, right? So in 2, 5, 3, instead of being in row 1, 2, 5, 3 is going to be in row 2. And 1, negative 2, 4, instead of being in row 2 now, is going to be in row 1. All right, so we can also multiply any row by a non-zero constant. So can't be 0 because that would wipe out all of our numbers, right? But any other constant. And we would write this like this, that negative 2 times row 2, and then this arrow means that it's going to be our new row 2. Okay? Then we can also add a non-zero multiple of 1, so we can multiply one row by a number, and then we can add it to another row. And it would look something like this. If we were going to we're going to multiply the top row by negative 2, we'd add it to the second row, and that will be our new second row. So one of the keys here is, and you'll see this as we start doing some problems, is that we only change one row at a time. I might use the other row to add to something, but I only change the one row. Okay? So that should make more sense. But these are the 3 things that we can do. And they make sense since this is an equation. We, of course, could multiply as long as we do both sides of the equal sign, and as long as we do all 3 columns here, or all 4 if we're in if we have 3 equations. As long as we do all of them, including the answer, then we're keeping it equal. Okay, so this is the first one we're going to do. We're going to do this little 2 equations, 2 variables. So I want you to transfer those numbers over there. If you want to pause the video for a second so you can get that done before I do it for you, so that you can learn how to do it, right? All right, so we're going to have a 1 2 and a 5 on the top one, a 3, a -1, and a -13 on the bottom one. Hopefully you can read that. I know those little boxes are a little darker than I wanted them, but they're what they are. Okay, so there's our matrix, and that's what we're going to use. So always our first goal is to get a 1 right here in the top left-hand corner. Okay, now in this case, it's already a 1, so I don't have to worry about that. My second goal is always going to be get a 0 right below that 1. Okay, so I want to get a 0 right here. And I'm going to do that by using those 3 row operations, okay? So I want to multiply, if I multiply the whole top row by -3, and I add it to the second row, then that would give me a 0 in the first spot. Now the rest of them will be changed too, but, okay, let's get back here, all right. Okay, so that's what I'm going to start with. A -1 times -3 times row 1. Okay, so -3 times row 1 is going to be -3, -6, and -15. I'm going to add that to row 2. It's going to be 0, -7, -28. Now you notice that I used row 1, I used it and multiplied it by -3, but I'm not changing row 1. This right here is the only row that gets changed. I'm replacing row 2. Row 1, I already have a 1 in the first place. I don't want to mess that up. Okay, but the second row now will be 0, -7, -28. Okay, so here's that. This should be what you had for your for that matrix, right? Now the next goal is always going to be to get this to be a 1. So if you notice that these are the diagonals. I mentioned diagonals on that other screen, but I think I forgot to point out what they were. But we want those to be 1s. Okay. So the best way for me to get this to be a 1 is to just divide. Now I know you might be thinking, well, I could multiply the top one by 4 and add it to it, but what that's going to do is mess up my 0. So at this point, I don't want to add, I can't use the top row to add to this, or it's going to mess up my 0 that I already did. So at this point, I just need to divide by -7. So this is how I wrote it. Multiplying by -1/7, same thing as dividing by -7, right? So my new bottom row, so 0 divided by -7 is still going to be 0. -7 divided by -7 is going to be a 1. And -28 divided by -7 is going to be a 4. Okay, so this is what we call row echelon form. So in row echelon form, I have 1s on the diagonals, or as close to the diagonals as we can, with a 0 below any 1s. Okay, now here are the actual rules, because sometimes it won't turn out that we can get all the 1s on the diagonal, and sometimes we end up with rows of all 0s, as we'll talk about in the next section. But so if there is a row of all 0s, it's got to be at the bottom. For all the rows, the first non-zero number has to be a 1. So in the top row, there aren't any non-zeros, so we will just have it be a 1 right here, right? In the second one, there is a 0, but then the first non-zero is a 1 right there. So we've met that. So that one is called, they refer to that as the leading one. And when you put the rows in order, the leading one has to be farther to the right, the farther down it goes, right? So if I switched these rows, which is perfectly allowable, that was one of our row operations to switch them. But if I did, then the top row would have the top row would be 0, 1, 4, and the bottom row would be 1, 2, 5. And you see how that wouldn't fit that rule, right? Because the leading one in each non-zero row is to the right of the one above it. So this one is not to the right, it's to the left. So this would not be in row echelon form. Okay, now we will talk a little bit more later, but we might as well, right now, while we're talking about row echelon forms, talk about the fact we can sometimes have reduced row echelon form. So it has all the rules of row echelon form. In addition, each row that has a 1 has zeros above it as well as below it, right? So if we had something that looked like this, right, then this would be in row echelon form because I have my 1s on the diagonal and there's zeros both below it and above it. Okay, now let's go back to our thing, back to the problem we were doing. Here we have, this is in row echelon form. Here are my 1s. There's a 0 below the 1. And this is when you know with Gaussian elimination that you can stop. So now let's put it back into the equations that we started with, right? So the top one would be just an x plus 2y equals 5. That's the way we did it, right? The first rows are the x's and then the y's and then the answers. This would be 0x, so I can just leave that off, y equals 4. So you see what happened is I already solved part of my answer, right? I got y equals 4, and then I get x by just plugging that 4 back in. So I plug it in, and I end up with -3. Okay, so that is called solving a system of equations with Gaussian elimination. Now, we can do this with 3 equations and 3 variables. And I know this is kind of where it gets complicated. It gets longer, right? It's not really complicated. It still follows the same rules. And I know that you're going to get done and say, oh my gosh, that's so much work. Why can't I just do it the way we did it in the last chapter? Well, I will tell you that if somebody gave me a system of 3 equations and 3 variables to solve right now, I would throw it into a matrix, okay? Once you get used to it, it's easier to do it. So keep that in mind. Don't have a closed mind about this. So we do the same. We're going to do the same thing we did before, only there's 3 of them, but first thing we have to do is put it into a matrix. So transfer those coefficients into the matrix. Didn't leave this a very good place for me to write. Oh, there we go. It made it big. Okay, I got 3. Oh, darn. Now I don't have the system. Okay, go back. Go back. There we go. So in every case, the x's are in the first column, the y's are in the second column, the z's are in the third column, and the answers are in the fourth column. Okay. All right, so we still have the same kind of goals. Our first goal is to get a 1 right here. And then we'll get zeros below it. And then we'll get a 1 right here. And then we'll get a 0 below it. And then we'll get a 1 right here. And then we'll have it in row echelon form. Okay, so get rid of that first. Well, we first of all just look at how could I get a 1 in that top left-hand corner, and you want it to be as simple as possible. Now, one way I could do that is by dividing the whole row by 3, and that's a totally valid way to do it. And some people teach it just, that's what you do. You divide it by that number. But it seems like I'd rather work without fractions. So in my mind, I have a 1 right here. So let's just switch these rows. That seems like a pretty easy thing to do, right? So I'm going to write the second row in the first row's place and the first row in the second row's place, right? So this will be 1, 3, 7, 5, 3, 5, 9, 3. Okay. All right, so that one was pretty easy. Now, remember the next thing we wanted to do was get a 0 right below the 1. Well, so just like we did before, we're going to use the row operations. We're going to multiply one row and add it to another row to get that. I just care about this 3 being a 0. Okay, so if I use the 1 I got up on top, multiply by -3, got -3, -9, -21, -15, that looks like a 7 or something. I'm going to add that to 3, 5, 9, 3. So I have 0, -4, -12, -12. Okay, so those are the numbers that are going over here. I got 0, -4, -12, -12. Okay, so now we have the 0 below the 1. I need a 0 below that. So I want to get this -2 to be a 0. So I will use my top 1 again and multiply it by 2 and add it to row 3. And we notice that this time I'm only changing row 3. The other 2 are staying the same. I got them where I want them. I got the 1 and the 0 just right. So I'm only changing row 3. So I'm going to multiply row 1 by 2. 6, 14, and 10. And then I'm going to add it to row 3. That'll be 0, -2, -1, -1. I'm sorry about the handwriting with this stylus. Okay, so that's going to be 0, -2, -1, -1. Okay, so the next goal is to get the next 1 on our diagonal, right? So I want to get this to be a 1. Now, sometimes it's possible to multiply the bottom row by something and add to it, but not in this case because it would give me 0. I do not want to add anything with the top row because anything that I wanted to multiply by the top row and add it to the second row is going to mess up this 0 right here because the 1 will be added to the 0. So I can't add the first row to the second row again. All right, so what I'm going to do is I'm going to make that, I'm going to divide. If I just divide by -4, that whole second row, then that'll give me a 1 there. So 0 divided by -4 is still going to be 0. -4 divided by -4 is 1. -12 divided by -4 will be 3. And -12 divided by -4 will be 3 again. Okay, so I got my 1 here. So now I need to get a 0 right below it. So I'm going to use that 1, and I'm going to multiply by 2 and add it to the third row. Now, this time it's okay. I won't mess anything up because these are both zeros, so that won't interfere. So I'm going to multiply row 2 by 2. So I have 0, 2, 6, 6. I'm going to add that to row 3, which is 0, -2, -1, -1. So I get 0, 0, 5, 5. All right, so that's what goes right here. We got 0, 0, 5, 5. And then now we want to get a 1. I need a 1 right here. And I can't use any of the other rows because they'll mess up my zeros. I just need to divide. So I'm going to divide the bottom row by 5. So 0 divided by 5 is 0. And then another 0. 5 divided by 5 is 1. And 5 divided by 5 is 1. And ta-da! We have row echelon form. I have all my 1s here. Whoops. I have all my 1s here. And I can now change it back into the equations. So when I change this back into equations, I'm going to start with the bottom row because that one's already ready to go. Z is equal to 1. Okay. So the second row, the x is 0, so I just have y plus 3z equals 3, or if I substitute 1 for z, I got y plus 3 equals 3. That means y has to be 0. And then the last one I would do x plus 3y plus 7z equals 5. That's coming from the top row. Whoops. Come on. And if I plug in the y is 0 and the z is 1 into those places, I get x plus 0, or x plus 7 equals 5, so I subtract 7, and I get x equals -2. So when you write your answer, you're going to do it as an ordered triple, so it will look like this, -2, 0, and 1. All right, and so that's how we can solve a system of 3 equations. Now, there was a guy, Wilhelm Jordan, who kind of extended Gauss's method and went just a little bit further, and we would use row operations to get all the way to reduced row echelon form. So in reduced row echelon form, if you notice, so this is not our same problem, this is a different problem. But if I change this back to equations, I just have an x, right? I just have x. So x is equal to 3, y is equal to -4, and z is equal to -1. And so it just gives you the answer. You can just read it right off, right? So that's why we like reduced row echelon form. So let's go back and pick up the same problem we were doing. We got it to row echelon form, and then we went ahead and changed it to equations. But instead of changing it to equations, if we had just kept going, we only have 3 more steps, and we would have it all, we wouldn't have to do any substitution. Okay, so now that we have these ones here, we're going to kind of work backwards. I'm going to use row 3 and get zeros above the 1, right? So you notice that I have zeros over here, so when I add row 3 to other things, it's not going to change anything in the first 2 columns. It's just going to change stuff in the answer or the Z column. So I'm going to start by doing -3 times row 3 and add it to row 2 to make a new row 2, right? So I'm just changing row 2 this time. And when I do -3 on row 3, I get 0, 0, -3, -3. And row 2 then gives me 0, 1, 0, 0. Okay. All right, so if you notice now, we have all the zeros in the bottom 2 rows. Now, I use row 3. I use row 3 and take care of this number. And so I'm going to multiply the bottom row by -7 and add it to the top row. When I multiply the bottom row by -7, I get 0, 0, -7, -7. I'm going to add it to the top row. 1, 3, 0, -2. Okay, so now hopefully you can see the last thing we have to get rid of. Can you see it? I hope that you are noticing that it is that 3 right there. So you notice now I can't use row 3 anymore because there's nothing there. But row 2 has a 1 there, and there are zeros on either side, so it won't mess up the 1 or the 0 we already worked to get. Right? It will just change this. So if we multiply row 2 by -3, I'm going to add it to row 1, 1, 0, 0, -2. Okay, let me erase all my writing here. Okay, so you can see that that answer is, I can just read it right off, right? The x is the -2, the y is the 0, and the 1 is the 1. And those are the same answers we got when we did it by, we stopped and we did the back substitution with the algebraic equations. But Gauss-Jordan, you can just do it all in matrices and get it all the way down. Okay, here's your last thing. This is a practice problem. It's just a small one. But pause the video and see if you can solve this using Gauss-Jordan method. If you pause it, if you get stuck, start it back up, and I'll try to give you a hint first before I tell you the actual answers. All right, so here is how the matrix looks. And the hint is that the first thing you'd want to do is switch row 1 and row 2. So do row 1 switched with row 2 to start with, and then get a 0 right below that. All right, so we're going to do -4 times row 1, add that to row 2, that'll be my new row 2. So the row 1 stays the same. -4 plus 4 is 0. -4 times -2 is 8. Minus 7 is 1. And -4 times 1 is 4. Plus 1 is 5. If you notice, I already have my y value. I just have to plug that in if I'm stopping and doing Gauss-Jordan. If I want to do one more matrix to get that Gauss-Jordan method, I would do 2 times row 2 added to row 1 to make a new row 1. Means I've already got row 2 done. I don't want to change that. I'm going to multiply row 2 by 2, so that still will be 1 because 0 times 2. And then 1 times 2 is 2 plus 2 is 0. 5 times 2 is 10 minus 1 is 9. So the answer is 9, 5, and you should write your answer as an ordered pair. All right, take a picture of your worksheet and upload it, and come on during class time, and we will discuss any questions you have, maybe work out more problems if you need that. So I'll see you in class.